Good day, grade 12. This is our third video in our series on fertilizers. In the first two videos, in the first video we looked at our primary nutrients and we looked at our mineral nutrients, and then we discussed in the last video the Haber process. In this video we will have a look at the Oslo process that is used for the manufacturing of nitric acid. Okay, the Oslo process consists of three basic steps. In our first step we have the reaction between oxygen and ammonia. The step has its own name, the catalytic oxidation of ammonia. Now when you've done oxidation reduction reactions, I think you have learned that the reaction with oxygen that was our very first primitive oxidation reaction. Okay, so you have to know that this very first step of the Oslo process where oxygen react with ammonia to produce nitrogen oxide and water, or nitrogen monoxide and water. This step is called the catalytic oxidation of ammonia. I'm going to go through the three steps, but I'm not going to balance these equations yet. At quick glance, you should see that this equation is not balanced. If nothing else, here I have two hydrogens and they've got three hydrogens, so this is not balanced yet. But let's first see what the three steps of the Oslo process are. Okay, so I start out with a catalytic oxidation of ammonia to create nitrogen monoxide and water. Once I've created the nitrogen monoxide, I oxidate that again, or let it react with oxygen to give me nitrogen dioxide. And in my final step, I take the nitrogen dioxide, react it with water to get nitric oxide, and one of the byproducts will be nitrogen monoxide. Now this nitrogen monoxide I can put back into my process in the manufacturing so that it can produce again some more NO2, and so the process continues. So there's three steps: catalytic oxidation of ammonia, then ammonium monoxide that I had as product in the previous step to give me nitrogen dioxide, and then the last step, nitrogen dioxide plus water to give me nitric acid. So now let's start and see if we can balance these equations. I think that's the hard part of the Oslo process to memorize. Okay, so let's start with our basic equation. First we check the amount of nitrogens. Nitrogens look okay. I always keep the oxygens for last. Some teachers will tell you do the oxygens first, because if you sort them out, then usually all the rest is sorted out. Personally, I do them last because they usually are the difficult part to figure out, because usually you get your oxygens in more than one compound. So I kind of leave it for last and rely on the fact that the other elements will kind of take care of the balancing, and often this works. Okay, so I'm going to leave my oxygens for last. Nitrogens at this stage work out. Hydrogens, I have 3 on this side and I only have 2 on that side, so I'm definitely going to need more hydrogens, or balance my hydrogens, and I'm going to try to make a total of 6 hydrogens. Okay, so if I add, because this is the only substance that is giving me hydrogens, so if I add a 3 on this side, that will give me 6 hydrogen atoms as products, and if I add a 2 in front here, that will give me 6 hydrogen atoms as reactants. Okay, so now I see I've got, now my nitrogens are upset again, so let's check the nitrogens. I have 2 nitrogens on this side and only 1 nitrogen on that side, so I add a 2. Nitrogens are balanced, hydrogens are balanced. Let's have a look at the oxygens. On this side I have 2 oxygens, on this side I've got 1, 2, 3, 4, 5. Now here is a problem. Can you see on this side I've got an uneven, all my other numbers are balanced, but I have an uneven number of oxygens, and on this side I will always get an even number because I have oxygen here as a diatomic molecule. Here is a trick that sometimes works. If you have that all the atoms are balanced except for 1, and you have a situation that you need an even number on the one side and an uneven number on the other side. take your existing balancing numbers and just double them. So instead of a 2 here, I'm going to have a 4. Instead of a 2 here, I'll have a 4. And instead of a 3 here, I'll have a 6. Okay, and now let's see what happens if I try to figure out oxygen. Now, just for the sake of being thorough, let me check all my atoms again. I've got 4 nitrogens as reactants, and I have 4 nitrogens as products. Nitrogen check. I have 12 hydrogens as reactants. I have 12 hydrogens as product. Hydrogen check. Oxygen, I've got 4 plus 6. I've got 10 oxygens as products, but now it's an even number. So I can sort this one out here by just adding a 5. And there's my balanced equation for the catalytic oxidation of ammonia. You can either learn how to balance it so that you know the different steps, so you kind of remember, work out all the numbers, double the numbers before you get to the oxygens, and then work out the oxygen, so you can memorize those steps. Or you can memorize this equation like a telephone number. 4NH3 plus 5O2 will give you 4NO plus 6H2O. However you memorize that, as long as you are able to write out this question in the exam, or this equation in the exam, you are okay. Let's look at the next step. Now I have the nitrogen monoxide, which I react with the oxygens. Okay, nitrogen work out on both sides. Oxygen, I have 1 to 3 on this side and 2 oxygens on that side. So I don't have enough oxygens on this side. So let me just add some more, at least another molecule. So I have 2 molecules on this side. So now I've got 2 nitrogens here and 4 oxygens. Since I have 2 nitrogens here, I needed 2 on this side as well. And now you will see 2 nitrogens and 1, 2, 3, 4 oxygens, where I have 1, 2 nitrogens and 4 oxygens, so this equation is balanced. The last step of the Oslo process is NO2 plus water, which will give me HNO3 plus NO. Okay, I'm going to cheat a little bit in this equation, just not to take the long way. Okay, remember I said don't do the oxygens first, because sometimes they appear in all my substances and it makes it difficult. Okay, now for almost the same reason, I'm not going to start with the nitrogens either, because I've got a nitrogen on this side and I have a nitrogen on this side and this side as well. I'm going to start with the hydrogens, because I know the number here of hydrogens in this element and the number of hydrogens not in this element, in this compound, and the number of hydrogens in this compound must be the same. So here I see I've got 2 hydrogens on that side, so I'm going to have add myself a 2 over here. And now let's see what happens with the balancing. So I have 1 nitrogen on this side, and I've got 1, 2, 3 nitrogens on that side. So I need another 3 in front of my end products. Okay, so now we have, let me just quickly check everything that we have. The nitrogens, 3 on this side, 1, 2, 3 on that side. Nitrogen is balanced. Let's check the hydrogen again. Okay, the hydrogen is 2 on this side, 2 on that side. Hydrogen is balanced. So what happened with the oxygens? Okay, in total, in the NO2, I've got 3 molecules, so I have 6 oxygens over here, plus that one is 7 oxygens as reactants. And let's see what opened over here. 2 times O3s, that will give me 6 oxygens plus another oxygen, 7. So I have 7 oxygens as part of my reactants, as well as 7 oxygens part of my products. So this equation is balanced. And there is the complete Oslo process. All that I need to remember is this one product, nitrogen monoxide, I just pump back into the system to give me the Oslo process. Okay, in our next video, we will have a look at the contact process.